Hey guys, this is the 2009 free response number 4. It's a 2-sample confidence interval for the difference in mean response times. If you guys want to take a second to read it, please do. I'm just going to really get right into it. Data were collected to investigate whether the council member's belief is correct. So this council member basically believes that the two fire stations have different mean response times. Okay? A random sample of 50 calls selected from the northern fire stations have a mean response time of 4.3 minutes with a standard deviation of 3.7 minutes. I highly recommend that you jot down all of the statistics. A random sample of 50 calls selected from the southern fire station has a mean response time of 5.3 with a standard deviation of 3.2. So in this case here, in both cases rather, the reason why it's S and not sigma is because the standard deviation came from the 50, okay? So that's why it's an S and not a sigma, and anytime we know that there's an S, we're going to do a T. Construct and interpret a 95% confidence interval for the difference in mean response times between the two fire stations. Okay. First, we know that all confidence intervals require 3 steps: conditions, formulas, interpretation. So the conditions, there's always 2 of them. The first one is, the stem of the problem states that both calls from the northern and southern half of town were random, and then we can assume that the calls are independent. So this tells us right here that it was random, and then it tells us again another random sample, and you have to assume that it's independent from one another. In other words, not both of them responded to the fire at the same time, and so on. So the stem of the problem states that both calls from the northern and southern half of town were random, and then we can assume the calls were independent. So that's your first condition. Your second condition is normality. So we need either a box plot or a dot plot or some type of graphical display, or they have to tell you, or for averages, not for proportions, for averages, if n is greater than 30, then by the central limit theorem, we can assume the distribution is approximately normal. So in this case, you have to say since n1 and n2 are both 50, which is greater than 30, then we can assume the distribution is approximately normal. Okay, so now your conditions are done. We go on to formula. We know it's a confidence interval. Statistic plus or minus critical value times the standard deviation of the statistic. Okay, so how do we do this? Difference of sample means plus or minus critical value times standard deviation of statistics. Remember that this is a 2-sample, okay? So this is going to be x bar 1 minus x bar 2. These are going to be S's and not sigmas. So on your formula sheet, it might say sigma. You have to replace it with S's. And then we have this special T. Now, you plug in all your mechanics, 4.3, 5.3, 3.7, and so on. Don't compute any of this. Let your calculator do it. This guy here, you can leave him as T star for now. You can go back and replace it later. But the way to find the actual value for this is you press second, vars, inverse T. You know it's a 95% confidence interval, which means that on each side there's 0.025. So that's why our area is this guy. You have 3 options for degrees of freedom. You could take the smaller of the 2 ends and do -1. Since they're both the same, it doesn't matter. Or you can add both ends and -2. So 50 plus 50 minus 2. Or you could get the one from the calculator, which is the one that you should, since you're using the answer of the calculator. So let's get to the calculator part, okay? You're going to have to press stat right there. Go to 2-sample T interval, okay? Plug in your numbers, everything for population 1 and population 2, and remind yourselves that you guys have to identify what mu1 and mu2 is. Define your parameter of interest in the beginning of the problem, okay? Remember, these are means, okay? So don't say this is northern, this is southern. These are means. So these are the mean response times from the northern fire station, the mean response time for the southern. You press no for your pooled, and you hit calculate, and you get this number. And then remember the degrees of freedom 96.0045. So you can come back here if you want the actual number and plug that in there, and you would get an actual t. Okay, so you get this here, negative 2.37 to positive 0.373. Great, that's your formula part. Now you gotta go, we did conditions, formula, interpretation. So based on these samples, we're 95% confident that the true difference in mean time responses is between this number and that number. And let's pretend that you don't remember how to write this. All you have to do is go back to your question and read what they want. They want this right here. Confidence interval for the difference in mean response times between the two fire stations. So you just say we're 95% confident that the difference in mean response time between the two fire stations between this number and that number. Now, I wrote up here 2 samples means 2 statements. Typically, they ask them in 2 separate questions. So it says, does the confidence interval in part A support the council members' belief that the 2 fire stations have different mean response times? Well, this has a negative, this has a positive. So we know that a number that's between a negative and a positive is 0. So since 0 is in the interval, we don't have evidence of a difference in mean response time at the alpha equals 0.05. In other words, sometimes one of them gets there faster, sometimes the other one gets there faster, and so on. Had these both been positive or these both been negative, then we do support the council's belief. But because 0's in the interval, we don't support his belief. And that's how you do this problem. Take your time, pause the video, and try it yourself, reread the question, and so on.